Hello everyone, I'm going through the Sec 2 NA worksheet on work and energy, and I'll begin with the part on work done first. Now, in this first question, they require you to understand what is the meaning of work done. So remember, the formula for work is force times distance. So you first need to apply a force on an object, and then this object must move in the direction of the force. So basically your force and distance must be parallel to one another. So the correct answer for question 1 should be D. Work is done only when the object moves in the direction of the applied force. So B and C, you notice that they only talk about the force or the distance, but in this case, work is not done. You need to first apply a force and the object must also move. For option 1, it's important to remember that the definition for energy is that it is the capacity to do work. So if you want to do work, you need energy. Without energy, no work can be done. Question 2, for SI unit, please do remember that it is in joules. And of course, remember just now we said that you want to do work, you must have energy. So that's why joules is also the same unit for energy. So you want to do 1 joule of work, you must have 1 joule of energy. Question 3, they ask you to decide which is the one, under which scenario A, B, C, D will the most work be done. Now, all the 4 scenarios, a man is pushing a box. The mass of the box may differ, but the box are all moving. So in this case, again, let's remember that work done is force times distance. So what we do is to calculate the work done for all the 4 scenarios. So the forces in the 4 scenarios are different and the distance are also different. So what I'll do is I'll multiply them and the answers are given here. All right. You may wonder why is it that I didn't do anything about the mass of the box. Now in this case, this is actually a distractor. So this part here, this information is not important, right? I only need the force and the distance. So A is the largest amount of work done at 150. Question 4, it is a calculation for work done. Again, force times distance. You apply 0.5 newtons, the box moves 1.5 meters. So the work done will be 0.75. Question 5. Now for question 5, the work done is given, the distance is given, and then you will then find the force. I think there's a little bit of error here. This one, you don't need to do calculation. This is just 0.2 directly. Okay, so the answer is 100 newtons. Question 6. Now, all the calculation question, I need you to be very careful with the way you present your answers. Now, for all calculation question, please have the good habit of stating the formula. So this is where you state formula, right? And then you must show the substitution. So what do you mean by substitution? Now, this is substitution, right? So you substitute the value. So when you say F, this is F. When you say D, this is D. And finally, your final answer have to be given in the correct units. So the units must be stated. And can I also just remind you that if it is a long string of numbers, to give your answer to 3 significant figures, whether it's decimal or not decimals, it doesn't matter. As long as you have anything more than 3 significant figures, you have to round it off to 3 SF. And definitely there should be no fraction, right? So please remember, no fraction is to be given as your answer. So let's begin now. For question 6, the force is given, the distance is given. So let's look at your own answer and make sure that you present it in this way, 3 steps. Your answer is 1007. Question 7. Question 7, you have to find the distance. You have to calculate again the work done for this girl, and this one again, there's a little bit of a mistake here. This should be just 0.5. right? So sorry, this should be just 0.5. So the answer is 75 joules. Let's go on to question 8. Question 8 is slightly different. You read the question, it says Benjamin runs up the flight of steps and then you're asked to calculate the work done. Now, they did not tell you how much force is needed to go up, but you need to know that for a person that is 600 newtons, okay, so this is, let's say this is Benjamin. If Benjamin's weight is 600 newtons, that means the earth will pull Benjamin with 600 newtons of force downwards. So in order for Benjamin to go up, up, and up the stairs, Benjamin then need to apply a force which is at least 600 newtons. Of course, Benjamin can apply more force. Then he will then move faster. But minimally, you need to apply at least 600 newtons of force. So in this case, the force will be the weight of Benjamin, right? Because Benjamin is weight is 600. So to lift Benjamin upwards, you need 600 newtons. Then because it's going vertically up, so when I multiply by distance, I'm going to take 0.5 as the distance because the force and the distance must be in the same direction. So this 0.6 is not needed in my calculation. I move on to question 9. Now, in question 9, the work done on the box, since I pushed with 10 newtons, it moved 0.2 meters, so it's a straightforward calculation. The answer is 2 joules. And then they ask if the floor is rough. Now, when the floor is rough, then you would expect that, so this is, let's say, a rough floor. So if you're trying to push a box through a rough floor, there will be friction that you need to overcome. And do note that each time there is friction and you try to overcome friction, then a lot of heat will be generated. The surface becomes very hot. Just like you rub your hands together, after that you feel that your hands become very hot, right? So when you overcome friction, heat is generated. So you can either put thermal energy or you could also give heat as the answer. Question 10. In this case, again, the work done is given, the force is given, and they ask for the distance. So you could, again, formula, substitution, and then final answer. Question 11. Now, for question 11, the box, the original position of the box is 20 centimeters, and at y, the distance according to the question is 120. So then we ask ourselves, from x to y, what is this distance? So 120 minus 20, so this is 100 centimeters, which is also equals to 1 meter. So we know the box moved 1 meter. And how much did we apply? We applied 30 newtons. Okay, so when you pull with 30 newtons, the box moved 1 meter in the same direction as the force, then the work done will be 30 joules. Let's go on to the last question. For this last question, the box is being pushed to go up, and they ask to calculate the work done to push the box from A to B. Which distance will you use? So again, remember our formula for work done is force times distance. The force is this force here because the question says it's the work done by the force in pushing the box. So we are referring to this force. So then what is this D here? What is this distance here? Well, remember, force and distance must be parallel and in the same direction. So therefore, I will take 4.5 to be the distance. I'm not going to take 4 meters or 3 meters. The reason is because if you look here, 3 meters is here, right? And wait a minute, let me just draw. And it will not be parallel to this force. 4 meters is here. Again, it is not parallel to this force, right? However, if you look closely, actually you don't have to look very closely because it's quite obvious. Let me just, yeah. So if you look now, the distance, the force here, and the distance of 4.5, they are parallel. So question 12, a distance of 4.5 should be used in the calculation because it is in the same direction as the applied force. Okay, so I'm done with the worksheet on work done. You may watch the other videos to do the corrections for energy 1 and energy 2. Happy learning!